In this video, we will solve problem 5.7 from the work McConkey, Applied Thermodynamics for Engineer and Technologists. So the statement of the problem is calculate the cycle efficiency. So here I written already, and the mean effective pressure. So here it is, mean effective pressures of an air standard diesel cycle. So the diesel cycle efficiency and the mean effective pressure we need to determine, and the compression ratio of 15/1, and the maximum and minimum cycle temperature of 1650 centigrade and 15 centigrade respectively. The maximum cycle pressure is 45 bar. So here the diesel cycles already written. So from process 1 to 2 is the adiabatic compression process, or you can say isentropic compression process. So here and the process 2 to 3 is the heat, where heat is supplied at a constant pressure, that is Q1, and this is the process. This is from process 3 to 4. This is, and here is the constant volume cooling. So here heat rejections is taken place. So that is Q2. The pressures at process 2 to 3 is constant, that is equal to P2 is equal to P3, and the volume at point 2 is V2, and the volume at V3 is at point 3 is V3, and the volume, as you know, it is a constant pressure volume, so the volume at point 4 and 1 is the same. So here I written this. Now come to the statement and toward its solutions. So here the statement say the cycle have with a compression ratio of 15/1. So it is compression ratio. So what the compression ratio say? So the maximum pressure volume of the system, that is V1 divided by V2, that is equal to compression ratio, it is equal to 15. Next is the maximum and minimum cycle temperature. So the maximum temperature, that will be T3, okay, not T2. So to convert that into Kelvin, just simply add 273 with it to convert that into Kelvin. So it will be equal to 1923 Kelvin. Next is the lowest temperature, that will be T1. So the T1 value is 15 centigrade plus 273. When you convert that into Kelvin, you will get 288 Kelvin. And the maximum cycle pressure that is given is that will be at point P2, but so the same pressure at P3 will be the same. So the maximum pressure at P2 and P3, that is 45 bar. So I can only write P2 is equal to P3 is equal to 45 bar. Now to find the efficiency of this cycle, at every point, at every state point, there the temperature should be determined. So the temperatures at T1 is already known, and the temperature at T2 is unknown. For that we will apply the isentropic formulas of the temperatures and volumes to get the temperature T2. So T2 divided by T1 is equal to V1 divided by V2 into gamma minus 1. So the what is T2 by T1? So the value of T2 is need to be determined. T1, V1 by V2 is 15, and gamma is 1.4. So 1.4 minus 1, that will be equal to 0.4. So if you further must simplify that, T2 divided by T1, it will equal to, now to find the T2, just multiply the value of temperature T1 with this value, you will get the T2. So 288 multiplied by 2.954. So the T2, the temperature T2 value you will get, that is 850.8 Kelvin. Next, the process 2 to 3 is the constant pressure process. So at a constant pressure process, so there is a direct relationship between temperature and volume. So temperature says from the gas law, PV is equal to RT. So this R and P is constant, so we have direct relationship with temperature. So I can write that V3 divided by V2 is equal to T3 divided by T2. So what is T3? That is 1923 divided by, and what is T2? That is 850.8. So when you divide this, you will get the ratio, that is T4. T3 is already given and T2 is determined, and T4 is need to be determined. The T4 value, V4 is basically equal to V1. So V1 divided by V2, that is equal to 15. So here I can write that V4 divided by V3, that is equal to 15 multiplied by V2 by V3. So this V2 by V3 is the reciprocal of this value. So here it is form 2.86. So in this way you will find its value, that is V4 divided by V3, that is equal to, so it is 2.26. So 15 divided by 2.26, you will get 6.64. So V4 by V3 volume ratio is 6.64. So from process 3 to 4 is again isentropic process. Now apply the isentropic formula of the temperatures and volumes. So T3 divided by T4 is equal to V4 divided by V3 into gamma minus 1. What is V4 by V3? That is 6.64 into gamma minus 1, that is equal to 0.4. After doing multiplications on calculators, T3 by T4 you will 2 to find the T4 value. So T4 value you will get, that is 902 Kelvin. So it's 900. So the temperature at every point is determined now, and we can easily proceed further. So the heat that is supplied is equal to, at a constant pressure, that will be equal to Cp, change in temperature. So the highest temperature is T3 minus T2. So Q1, that is equal to 1.005 into T3, 1923 minus T2, that is 850.8. So after doing simplifications on calculator, you will find its value, that is 1077.56 kilojoule per kg. Now to find the heat that is rejected, that is equal to Cv into change in temperature, that is equal to T4 minus T1. So C value is 0.718 into T4. T4 value is 902 minus T1 is 288. So after doing simplifications on calculator, you will find the heat that is rejected at a constant volume, that is 440.852 kilojoule per kg. The heat that is supplied is this one, and the heat that is rejected, that is this. So in diesel cycle, remember, the heat is supplied at a constant pressure and the heat is rejected at a constant volume. So the efficiency is now easy to determine. So the efficiency formula is now so to find the efficiency, we know the formula, that is heat supplied minus heat ejected divided by heat supplied. So the heat that is supplied, so this heat difference, so the heat that is supplied minus heat that is rejected, you can also say that it is a work done by the system. So work done by these diesel cycles, you can say, so the net work divided by heat that is supplied. So this Q1 minus Q2, Q1 is 1077.56 minus 440.852 divided by the heat that is supplied, 1077.56. So you will get the efficiency after simplification 1%. Next important thing that is need to be determined in this problem statement is to mean effective pressure. In order to find the mean effective pressure, you must know what is the mean effective pressure actually. So the work done by the cycles and per unit volume. So here the volume is under the piston. So the volume it is under the piston is V1 minus V2. So we already calculated the work done. This is the difference of the heat supplied and heat rejected, and the V1 and V2 is need to determine before finding the mean effective pressure. Divided by P2. What is P2? That is the maximum pressure, that is 45 bar. So to convert bar into Newton per meter square, just multiply that with 10 to the power 5. So this 10 to the power 5 is used with the pressure because of its unit conversion. After doing simplification, you will find the V2 value, that is 0.0543 meter cube per kg. Next is to find the V1 value. As we know the compression ratio, that is V1 by V2. So compression ratio is equal to 15. Just simply multiply this compression ratio. If you multiply both sides with this V2, we will find the V1. So the V1 is equal to 15 multiplied by V2. What is V2? That is 0.543. So after multiplication, you will get V1, that is 0.8139 meter cube per kg. To convert this whole value into bar, divide it with the 10 to the power 5 to find the mean effective pressure in terms of bar. And after simplification, you will get its value, that is 8.38 bar. So this is the final answers of this problem. Thank you so much for watching. More videos related to such type of problems are on the way. Please subscribe and share my channel with your friends. Thank you.